Bismillah Rahman Rahim. Welcome back, guys. Okay, so in the previous video, we talked about decanting as a process. And now in this video, we'll be talking about the second type of technique that we could use to separate a solid from a liquid. And this technique actually is more important than decanting uh, as far as your CIEs are concerned. Okay, so let's get started with them. The second technique is called filtration. Okay, and I'm pretty sure most of you might have heard about filtration or might have actually performed filtration. Now let's look at each and every step that we have in filtration. Okay, so let's get started. Okay, filtration, it is to say, okay, what do we mean by filtration? Filtration is used to separate small solid particles from a liquid. Okay, but what sort of solid particles? We did have solid particle in decanting as well. But what sort of solid particles do we separate out by filtration? The type of solid particles that we separate out are called suspensions. Okay, it's called a suspension. Let's read through the entire thing and then we'll get to know what we are actually dealing with. In general, we use filtration to separate small solids from a liquid. Examples of small solid particles include sand, clay, dust, particles, and precipitates. What are precipitates? Precipitates are actually small solid particles which are produced by in a liquid by chemical reaction. Basically, in easy words, precipitate is any insoluble solid present in a solution. It's called a precipitate. Okay, it's insoluble, it's a precipitate. It can either be localized in one position or spread throughout the liquid. When it is localized in one position, just like those pebbles in decanting example, these pebbles over here, just like these pebbles in water, they are localized. They can be separated out from the liquid, can be separated out from the pebbles by using decanting process. But what if the liquid, the pebbles or the solid or the precipitate is not localized? What if the precipitate is present throughout the liquid, spread throughout the liquid, just in like this example over here? In this example, if you look at this beaker which is full of a solution, in this solution we've got water, and throughout the water you can see there is a lot of sand present throughout the beaker. The sand isn't localized at one position, but rather it is present throughout the beaker. So this sand which is present throughout the beaker, such a solution is called not a solution, but rather it's called a suspension. It's called a suspension. Okay, what is a suspension? Suspension is any solution in which the precipitate is not localized, but rather is present throughout the liquid. Okay, so let's read through this part and then you'll figure out what it actually is telling us. How can we remove a precipitate from a reaction mixture by filtration? Okay, we've got a precipitate formed from a certain chemical reaction, and they've also given us an example of that reaction. And that reaction, what it does is it actually produces a liquid product and a solid product. That solid product is called a precipitate. Now, a white precipitate of lead-2 sulfate. Lead-2 sulfate is a compound. What is a compound? Compound is basically any substance that contains two or more elements which are chemically combined. Okay, let me just give it to you over here. What is a compound? Compound includes any substance having two or more than two, having two or more elements chemically combined. Okay, chemically is the key term over here. Do not miss it, or else you'll end up losing marks over here. Chemically combined. Okay, because in mixtures you've got substances which are not chemically combined, they are physically combined. This is the difference between a compound and a mixture. A compound includes substances which are chemically combined, and once this compound is formed, its chemical properties of the compound itself are completely different from the elements from which it is formed. Okay, for example, hydrogen and oxygen, these are two gases, two elements, right? When they chemically combine, they form water. Now, the chemical properties of hydrogen, the chemical properties of oxygen are completely different from chemical properties of water, H2O, water. Okay, so that's how a compound differs from its elements, and that's how a compound differs from a mixture. Now let's read through this paragraph. A white precipitate of lead-2 sulfate, lead-2 sulfate is a compound, is produced when we add sodium sulfate. This is one reactant, one compound, to lead-2 nitrate. This is in fact a chemical reaction that is taking place over here, and as a result of these two compounds, or yeah, as a result of these two reactants, I'll just write down their formulas over here. I'll tell you how to write down the formulas later on in the upcoming videos in different chapters, but again over here just writing it down, just assume, just believe me that yeah, these are correct. Sodium sulfate, Na2SO4 sodium sulfate, this is sodium sulfate, okay, in symbolic form. I will teach you how to write this formula for sodium sulfate. Do not panic. You don't need to know it right now in this chapter, but you will need to know it later on in the upcoming chapters. Sodium sulfate, when combines with lead nitrate, lead, Pb is the symbol for lead, and nitrate, NO3 it forms a white precipitate of lead sulfate, PbSO4, and sodium nitrate. Now, over here, as they told us in the question, that this is our precipitate. Sodium sulfate is our precipitate, PPT. This is our white precipitate. Now, how do we remove this precipitate from this mixture? This precipitate is present, and this is soluble salt that is formed, so it will dissolve in water. So now, how do we separate out the lead sulfate from this solution or from this mixture? The answer is simple. First of all, if you think that it's gonna we can use decanting, so let me tell you that this lead sulfate which is formed, it will be present throughout the solution, okay? It's not localized, so you cannot use decanting over here. The mixture will not be effective. Decanting the mixture will not be effective, as it is a suspension and not a solution, okay? Not a localized solid. It's a suspension. It's not a localized precipitate. So since it's a suspension, suspension means it is present evenly throughout the liquid, or present throughout the liquid. The solid is present throughout the liquid. Therefore, we cannot use decanting over here. We'll need to use filtration. Okay, and experiment 2, which we are going to look at in a bit, will illustrate how filtration is done. Okay. Similarly, like lead sulfate solution or lead sulfate mixture, this solution over here that we have, the suspension I should rather say over here we have, is also gonna be separated using filtration technique, because the solid in here, which is sand, is present throughout the liquid, is not localized, and no matter how long we allow it to stand, it won't settle down at the base, because sand is less dense. It's not that dense as pebbles, so it won't settle down. It will stay up, but that's why we cannot use decanting over here. Clear? Now we are gonna look at filtration. Now I just told you, I told you how filtration is done. I told you why filtration is done. I told you why decanting can't be done. Okay, and the type of solution on which decanting cannot be done is called a suspension. Okay, now we are going to look at the technique that can be used to separate out suspension in the next video. Okay, that is filtration. So stick around, and please stick around. Okay.